So in the demo, I'm going to discuss mainly what is big data, what is Hadoop, okay, and what is prerequisites to learn Hadoop, okay, and why big data is so popular in nowadays, and what is the roadmap of big data, okay, and how is the job opportunities and job market about big data. So why again? Like most of the projects are migrating towards big data, okay, and we're going to see what is data analytics, okay, how the big data and data analytics playing important role in today's market. Okay, so we're going to see a few things here. Okay, so let me start the demo. So before going to presentation, just let me start the demo with some simple real-time scenario. So for example, assume there is a customer. Assume there is some customer, okay, bank customer. So assume this customer visited this bank, okay. So let's take some bank, ICICI Bank. Okay, so a customer visited ICICI Bank, okay, and he requested for some bank statement. Maybe he requested for some 1 year bank statement, okay. So what will happen? The representative will log into the account, right, and he will take the printout and he will give it. Maybe the service, so maybe he will do the statement. So the service request will be closed maximum in 5 minutes, right? Okay, so now assume the second scenario. The same customer went to ICICI Bank, okay, but now he requested for some 10 years bank statement. Some 10 years, 15 years, 20 years bank statement, something for some financial purpose. He requested for some 10 years bank statement. But this time the representative, he will say, sir, you are requesting for historical transactional data. 10 years of the statement is something historical transactional data, which I cannot provide you immediately. I have to raise a request to backend system. Okay, I have to raise a request to backend system, and they will process the request, and you will receive the statement maybe in next 24 hours, and they'll charge some amount for that. Okay, so why the difference? When a customer requested for a statement here, 1 year statement, when this guy could able to provide it immediately, when the same customer requested for 10 year statement or some 15 years or 20 years, whatever it is, why can't you provide immediately? Okay, why he is raising request to backend system, and why the time taking process? So the reason is, so basically the data, like 1 year, 2 year, the recent data, it will always sit in our RDBMS systems, right? So the recent data, whatever we are going to maintain in organizations, it will sit always in our OLTP databases, that is RDBMS systems, like Oracle. It could be anything, Oracle or MySQL or Sybase or DB2 or Postgres. Okay, it could be any database. But in the second scenario, if you see when the customer requested for some historical transaction statement, okay, so he cannot provide immediately. Why? Because this historical data, like 20 years, 20 years, 30 years, 50 years, 100 years, okay, whatever the volume of data, period of data it is available, it will sit in backend systems, what we say, data warehouse systems, right? Like Teradata or maybe Neteria. Okay, it could be any warehouse system. Okay, so this guy has to raise a request to some backend system, these warehouse systems. So the warehouse systems, normally they will have batch. They'll have the batch jobs. Batch jobs mean scheduled jobs. Okay, so once the request comes, they cannot process immediately. Okay, the request will keep it in some queue, and once the job is scheduled, the jobs will run periodically. Okay, that's what we say. Batch job is nothing but it's a scheduled job. So they don't run all the time, they will run periodically based on the scheduling time, like once a day, once an hour, or maybe twice a day, like that. So most of the data warehouse system applications were what we say ETL applications. ETL applications, they are scheduled jobs. So once this request comes, they will keep the request in a queue and the application is started. So it will take the request, it has going to process the request, and it will send the statement back to customer. So obviously it will take at least some couple of hours. But if you go to big data systems, okay, if I go to big data systems, in both the scenarios, even if I request a 1 year data, if I request 10 year data, 50 years, 100 years of data, big data systems can provide you the data within the less time than what RDBMS systems are taking. Even it can do less than the 5 minutes of time, irrespective of volume of data you are requesting. Okay, so it can process and send you the volumes and volumes of data in less times using a mechanism called parallel processing mechanism. This is a very important and the core feature in big data that is playing important role in big data success. Okay, so this parallel processing mechanism is something what has been designed in the big data architecture. So it does the things. So, okay, so suppose here, if you go for any OLTP databases, I mean Oracle, MySQL, any databases, right? They're all designed on sequential processing mechanism. Suppose if I run a query, okay, so the query how it's going to load the data and run that query on the table. It's going to read the records one by one, and it's going to perform that query and it's going to return the result. That is what we say sequential processing. But if you go to big data systems, even the warehouse systems, most of the systems before they have followed sequential, but now, in the new versions, these guys also following this parallel processing mechanism. Big data, this is again guys, when I say parallel processing mechanism, this is not something newly invented in big data. This parallel processing mechanism, actually this architecture is implemented by Google in 2000s. It's implemented around 2002, 2003. Later, many companies adopted this that core principle in their products, in their tools, in their technologies, in their applications what they build. Even IBM, Microsoft, Oracle, many guys adopted this architecture. So similar way, Big Data also adopted this parallel processing mechanism. Big Data also adopted this parallel processing mechanism, but it did it in more optimal way. It's been implemented in more optimal way in Big Data. So there is a reason it's playing important role and key role in big data success. Okay, so we'll discuss more about this characteristic in detail in the course. And similarly, if you see the scalability. So the reason why, first of all, the data warehouse systems came into market and the RDBMS systems there. Okay, in traditional, in olden days, okay, why the data warehouse systems has been introduced? Because of the limitations in the RDBMS systems. Limitations. What are the limitations here? So these systems, they have storage limitations, right? If you take Oracle, MySQL, any database server, they have certain limitation how much they can handle the data. For example, if I take Oracle server, Oracle high-end database server can store maximum 16 terabyte of the data. 16 TB is maximum what it can handle. But if you see 16 TB is maybe it's not a small storage, it's a high storage only. But 16 TB is not only the data, right? Because if you see the companies are handling even terabytes and petabytes of data. So that is the reason to handle higher limitations of the data warehouse systems came into market. But they have again certain drawback in terms of scalability. So to make it more clear, So basically the data warehouse systems, right? They will run on clusters. So you guys may know what is a cluster, right? Cluster is nothing but it's a network where you will have n number of computers or nodes, whatever you say, connected to each other. So a cluster is nothing but it's a group of nodes connected to each other in a network. Okay, so this is cluster. Okay, so this is a 5-node cluster. Okay, it's a collection of nodes connected to each other in a network, and they can exchange data and they can communicate to each other. Any node can talk with any node. They're all in LAN basically. Okay, so when I say node is nothing but it's like our CPU cabinet. Okay, so a node will have its own hardware, its own hard disk, own RAM, own buffer, own motherboard, everything. So this is like collection of computers, what we say. Okay, but we say it's a collection of nodes. Node is like our one individual cabinet. So basically clusters by default runs with an architecture, what we say, master slave. It means they run as master slave. That means there will be one master system and remaining systems play slaves role. I mean, this is the default architecture. We have different architectures again. We have multi-master architecture. Okay, we have multi-master architecture. I mean, that we are going to discuss later in the Hadoop course. So assume this is a master system and these are all the slaves. Okay, like this is slave 1, this is slave 2, this is slave 3, this is slave 4. Okay, so this is a 5-node cluster, 1 master, 4 slaves. So you assume this is a Teradata cluster. Okay, why I'm telling all this is because Hadoop also follows the same cluster model. Hadoop also runs on the clusters. Okay, looks like so almost in similar way. Physically, they look like in similar model. So assume this is a Teradata cluster, some data warehouse cluster. So this is 5-node cluster. Assume this is a 2 TB. It has a 2 TB hard disk. It has 1 TB, 1 TB, 1 TB, 1 TB. So 4 plus 2, 6 TB capacity cluster. So 6 TB again is not big, right? One day my 6 TB is full. So what they will do? They have to add nodes. The ETL admin, he has to keep on adding nodes to the cluster. He has to keep on adding new nodes. So based on the demand, he will keep on adding. He is going to keep on adding the nodes to the cluster like this. But the problem here is when they want to add nodes to the clusters, they have to restart that complete system. Basically, they have to restart some services in the master. So basically, there will be certain maintenance activities they have to do. So the cluster will not be available. A complete cluster will not be available. So the challenge here is, as I said, the ETL, the Teradata systems or NetAsia systems, these ETL systems, they run mostly batch jobs. So batch jobs, right, is batch applications means, as I said, it's a scheduled jobs and they are automated jobs. Just they will trigger automatically by themselves and they will run for hours and even days. If you go for insurance, banking applications, right, the batch applications will run for days, even hours, long hours. So when some applications are running through scheduling, okay, something, any cluster upgradation is done. So restarting these things, right, it will impact the jobs what is running. So what they have to do, either they have to stop the jobs and then do the maintenance activities, but if jobs are stopped, it's going to impact the application. Why? Because batch applications are very important. Okay, these reports, whatever the outputs generated from batch applications, what we say batch reports. The batch reports are very important for day-to-day business activities. Depends on the batch reports. Most of the business activities will be planned in the organizations. I mean, today, based on today batch reports, tomorrow business plans will be there. So most of the decisions will be depends on this batch reports. So this batch reports plays an important role. Batch jobs plays important role. And they will run periodically, maybe daily, hourly, or whatever, depends on the application. So when some applications are running, if they want to, if the cluster is upgraded, if they want to do maintenance, that is very tough, maintenance activities. So basically what they do, ETL admin, they have to check off time, so where that no job is running, they have to do it, but that is very tough. That is the issue actually they are facing. So what they have to do, they have to intimate the team saying that, boss, don't schedule any jobs on so-and-so time and so-and-so date. Okay, so we are planning some maintenance activities for half an hour or 1 hour. Okay, so they will stop and they will, but that is not, again, good process, right? But if you go to Hadoop, so assume now this is a Hadoop cluster. Same situation, 6 node Hadoop cluster, so it is full. Hadoop admin added new nodes. Some Hadoop applications are running. So Hadoop also, they have to restart something, right? But Hadoop architecture again has a dynamic intelligence. So when the cluster is upgraded, that means when new nodes are added or some nodes are removed, without a single click or single command, basically without admin involvement, admin login itself, the Hadoop master has the intelligence. Dynamically, it will detect the nodes that is been added to the network and been removed from the network, and it will start replacing them. So basically, you don't need to do any maintenance activities, even restarts. So Hadoop has that intelligence. Dynamically, it will decide, it will identify the nodes that is been added to the network, and it will start replacing them. That's why we say Hadoop clusters are more linear scalable. Also, we say it's a horizontal scalable systems. And next, guys, similarly here, like hardware failures. So we know if a database is down, how it's going to impact our regular OLTP applications. I mean the web applications or mobile or enterprise applications who are dependent on that OLTP database. So that it's going to impact it. I mean, recently happened in many companies like Flipkart, Jet Airways. Of course, if the database server is down, nowadays they are maintaining the backup server. If main server fails, the backup server will be there. Okay, so active passive servers. If active server is down, passive server will become active. But in the worst case, both servers are down at the same time. So there will be no option. So your application should be down, will be down. So we know if an OLTP application is down, how much impact it will be there on the customer revenue as well as frame wise. So if you come to warehouse system again, so here let's take this diagram again. So assume I have some ETL application running, some warehouse application, some Teradata application is running. So it's running for last 4 hours. So almost some 80% of the processing is completed. Okay, so this application at 80% when it's running, unfortunately in the cluster, some node is dead. I mean some node is dead. That means it's failed because of some reason. Maybe hardware issue or power issue, whatever, the node is dead. So this application, whatever is running for last 4 hours, okay, now to finish remaining 20%, it needs some data from here. So what it will do? Since the node is gone, no more accessible, it will try and the application will fail. So whatever is spent the last 4 hours is going to waste. The resource, whatever is consumed, it's waste. Again, ETL admin has to fix this node. Again, they have to start. Again, it will take some 4 to 5 hours. But if you come to, again, Hadoop, guys, so assume the same scenario. So now assume this is a Hadoop application. Okay, so assume now I have some Hadoop application running, maybe from last 1 hour, so same like it's completed 80%. Okay. So at this scenario, again same situation, like one of the node in the cluster is dead. One of the node in the cluster is dead. One or two nodes maybe. Of course, there is a limit again, so the nodes are down, but this application to finish remaining 20%, it has a dependency on these nodes. It needs some data from here. So what normally happens if the node study is not accessible where the dependency is there, the application will try for some time and it will fail. But in Hadoop, in this scenario again, the applications which are running, if they have dependency on the failed nodes, so still the Hadoop master again plays important role. It will make sure that application, even if it has a dependency on the failed nodes, it will make sure this application will get successfully executed and get the results generated without any impact. Very, very powerful feature without any impact using a feature called replication. So Hadoop master has very dynamic intelligence available as part of framework itself. Okay, so it can handle any kind of hardware failures in the clusters. I mean, it will try to say like the node failures or the system failures will not impact the applications that is running currently in the cluster. That is good part in Hadoop. Okay, so it will make still the application get successfully executed and get the results generated. Next is the cost. So database systems, they are fine cost-wise, but they also, cost-wise, if you see the customers, they will pay good amount for maintenance and support. Every year they have to pay good amount for support and maintenance. But if you come to warehouse systems, guys, these are very, very, very costly. Teradata and Netezza, right? They are proprietary tools, proprietary even the ARC and the cluster. They need very high-end hardware models, high-end hardware configurations like 64 GB RAM, 32 GB RAM minimum. High-end hardware processors, very high-end. They demand high-end hardware models and hardware processors, and these technologies are proprietary, and they do charge very good amount for the support and license nodes every year. They are very, very costly in terms of processing and storage and everything. Suppose, for example, to make it clear, so assume I have some 1 TB data, I load it into Teradata cluster. So if I want to process 1 TB data in Teradata cluster, it's going to cost around $16,000 for the customer. But if I want to process same 1 TB data in Hadoop, right, it's going to cost maximum $3,000. So if you see the cost difference, it's more than 5 times cheaper. So the reason why Hadoop is so cheap in terms of cost is because the Hadoop architecture itself is designed mainly to run on commodity hardware. So commodity hardware means cheap hardware. Don't have any limitation saying that Hadoop needs this hardware, that hardware configurations. Don't have any limitations there. Hadoop can run on any kind of hardware models and hardware configurations. This is a major breakthrough in Hadoop, these two features. And these two are the main features why basically most of the projects are migrating to Hadoop. So especially the mainframe projects and warehouse system projects. Because any customer, right, family friends, they will see only two things. How far the cluster is available, how much is the downtime. So they want the cluster should be maximum 100% available. And second is cost. They want the thing to be done as much as less cost. So both can be achieved in Hadoop. That's why many mainframe and warehouse projects are migrating. If you see the customers who are from mainframes, right, after migrating Hadoop, in my experience I see Okay, they are saving around 60 to 70% of the cost what they used to spend before on mainframe systems. Even the warehouse systems, they are saving around 40 to 50% of the cost what they used to spend on the warehouse systems before. Okay, so this cost plays important role. And next is type of data. So friends, here till now maybe in our academics or projects, so you would have worked mostly with the databases only, right? And we know what databases is going to store. They store tables. That is structured data, relational data. That means we'll have schemas, then we'll have the data. That means we'll have the structured data, the data with some meaning, right? But Hadoop, so even these systems also they can process only structured data mostly. They can process semi-structured data like XML files, JSON files. But coming to Hadoop, Hadoop has the capability to process structured data as well as semi-structured data like XMLs and JSON files. It can process unstructured data. Unstructured data means the data which don't have any schemas, no meanings, no metas. It's a simple raw data and flat files. And it could be again any format. It could be text format, binary format, compressor format, document format. So Hadoop has the capability to process any type of data. And you know, the unstructured data is the volume of data available in the world right now, it's more unstructured compared to structured. If we say I have total data available in the world is 100%, so the volume of unstructured data itself is around more than 80%. Only structured data is 20%. Why? Because see, this unstructured data plays very important role again in real time. And why such a huge volumes of unstructured data is generated means because the sources who generate unstructured data are more comparing to sources who generate structured data. For example, if you see unstructured data, if you take satellite data, some military surveillance data, some biological surveillance data, okay, call center data, social networking data, like Twitter data, Facebook data, charts, messages, blogs, videos, graphs. Okay, so any call center data, social networking data, logs, application logs, web logs. So these data if you see is mostly unstructured. They don't have any schemas. So Hadoop has capability to process any type of data. Next again sets of data. Hadoop has capability to process GBs of data, terabytes of data, petabytes of data, exabytes of data, zettabytes of data, petabytes of data. Of course, we don't have such volumes of data right now in the world. If you take total data as well, it will be in zettabytes right now, but there are companies that are handling in exabytes and petabytes, bigger companies. So middle range companies mostly in petabytes and terabytes, small range companies mostly in terabytes. So Hadoop can do any volume of data. There is no concern there. And last but not least is the application development time. So friends, first of all, Hadoop we use mainly for data analytics. So these analytics again we have two categories. One is batch analytics, and one is real-time analytics. Real-time means it's nothing but OLAP, online analytical processing systems. So this batch analytics, what already the data warehouse systems are doing, but still we can do the same in Hadoop in more better way and optimal way. But this is what the market is expecting currently, and the competition is there in the market, the real-time analytics. Okay, so the decision should be taken just on the fly by processing some high volumes of data. That's what is expected from real-time analysis. They have to process some terabytes of data just within seconds and microseconds. So Hadoop has capability to do both batch analytics and real-time analytics. So if you want to do analytics in Hadoop, right, again friends, Hadoop is not a single solution technology. I mean like Hadoop, you don't say like, okay, this is my API, you have to use this to write a coding. In Hadoop, if you want to do data analytics, right, you have n number of alternatives is there. That means you can do analytics. I mean you can implement analytics in MapReduce. So this is one of the alternative. Similarly, you can do it in Pig, you can do it in Hive, you can do it in HBase. So these are all alternatives to do data analytics in Hadoop. Cassandra, Cascading, Tides, okay, Tides, SDK, and Spark, and Scala, and Hawk, okay, and Star. So if you write right, there is a very big list. Star, okay, MongoDB, CouchDB, Waldemar. So like this, many things is there, guys. Impala. So these are all alternatives available in Hadoop to do data analytics. Alternatives means these are all APIs and frameworks available in Hadoop. So that's why I say Hadoop is not single solution. If you want to do analytics in Hadoop, you have plenty of options is there. So these are all different frameworks. Every except MapReduce, right? Except MapReduce, we call all of them as ecosystems. So all these are open source again. So if you want to do analytics, you can do it in Pig or Hive or HBase or Cassandra or anything. So Hadoop just has that flexibility. And you know, these ecosystems, they are very powerful. They have very powerful engine. Okay, they have their own APIs for implementation. And they are simple to learn and easy to use. That's why they are ruling big data, mainly the Hadoop market, the ecosystems. So again, learning these ecosystems, you don't need to know any pre-programming language or something, because they are all fresh and new APIs. And something like if you know any query language like SQL or something, so still it will be easy to work on Hive because they follow same syntax, same everything, Hive, Impala, Cassandra. So Pig, right, if you sit hardly 4 to 5 days, you can learn Pig. Hive also something. Even not only the ecosystems, I mean, they have flexibility in development. Even, what is that, in terms of even the development. Suppose, why the ecosystems are built is because the drawbacks in MapReduce. MapReduce is the very core for Hadoop development. But if you use ecosystems, you don't need to know MapReduce, because doing analytics in MapReduce is very time-taking process and complex process, because you have to write some bundles and bundles of code, and the code maintenance will be difficult. So many things. So that's why the ecosystems are introduced by different guys, and all are open source. And learning these ecosystems, you don't need any pre-programming experience. You can straight away learn. So, but these are all ecosystems. So MapReduce, there are certain projects which are implemented in MapReduce as well. Any project is there. I mean, the beginning projects which were started in Hadoop, most of them follow the MapReduce. So, but the bad thing in MapReduce is you have to know some programming language to work with MapReduce. You have to know, again, it's not limited to one programming. You can do MapReduce programming in C++, in Python, in Ruby, in Perl, in Java, in Shell. You can use any programming language to do MapReduce program. Okay, you can. Okay, we can need to write MapReduce programs to do this functionality. Okay, so we need to know the programming language like anything. Okay, you have, I mean, if you know any programming language, you can write MR programs. Okay, so basically you need to have a programming language, and again writing this complex code is very tough. It's difficult to maintain and debug that code. That's why the ecosystems are came. So they're all wrappers on top of MapReduce. So the thing, suppose if I write some 1,000 lines of code in MapReduce, it's the same I write in Big Maxons at some 50 lines. Similarly, if I do in Hive, still it will be lesser. So that is a goodness in ecosystem. Development will be fast, testing will be fast, maintenance will be easier. Okay, so but since this is a course, we need to cover from end to end. We are going to cover all the MapReduce in the ecosystems. Even for MapReduce, since we need to know some programming language, so I'll be taking some classes, some 6 to 7 classes on core Java along with practicals. To make a little comfort for MapReduce. Okay. So in real time, if you go, most of the 80% of projects uses ecosystem for development. Only some 20-25% projects will use MapReduce, even not 25, less than 40%. Because these things, right, they are very powerful and they will do things, many things. Okay. So like this, we have many ecosystems, friends. So Hadoop has this many features and characteristics for data analytics, and these are the main reasons why most of the things are looking towards Hadoop. Okay, so let's go to presentation. So in the presentation, this is about myself, leave it. So it is a study has been done by International Data Center. Okay, they are saying that the data, how fast it's growing day to day in the market. So they are saying in 2009 the volume of data in the world is to 8 lakh petabytes, but it's going to reach 35 gigabytes in coming future. That means by 2020, 35 billion terabytes. So how fast the data is growing? Because the data sources who are generated, like if you see right, even the ATM machines. Okay, simple. Any retail, if you go to retail, e-commerce, shopping, everywhere, data keeps on generating data. Okay, so the data, whatever is been receiving daily, day to day, it's increasing. We should be able to utilize them for doing proper analytics. Okay, so we cannot discard the data, right? Because this data will help you. If you do certain analysis on this data, it will help you to take certain business decisions, to come up with better services, to come up with new business strategies, to give competition for competitors, to increase the revenue count, to increase the customer count. So this analytics plays very, very important role on these volumes of data. Okay, so again, to do this data analytics, okay, we should be able to understand the data, what type of data are we handling. Okay, and then we need good storage system to store the data. We need good framework to write the applications. We need, we need again good network bandwidth, network infrastructure, the cluster setup, and these are all the expensive with the existing solutions like the warehouse systems or maybe whatever alternatives available. Okay, they are more expensive, slow and to write, and they do follow mostly sequential processing, which is time taking. So is the reason the alternative, right? BK came into market as big data. Okay. So again, coming to analytics, we have different kind of analytics guys. We have predictive analytics, we have sentimental analytics, strategic analytics, recommendation analytics, feedback analytics. Okay, so we are going to cover this use cases category wise, some of the use cases in each category in our practicals, as well as when we do the project as well, we are going to do some use cases there. So there are many categories. Okay, so we are going to do few from here. Okay, so these are all Hadoop internals. Okay, so how the data is going to represent in big data? Is it like a table format or some file format? How Hadoop is going to store the data? So we have, again, it has its own different mechanisms. Okay, so it can deal any type of data with different computation capabilities, like in-memory is one capability, NoSQL databases, so large scale NoSQL databases, like like whatever situation, everything. Okay, so these are all different options. And coming to job market again, so I mean right now it's very good, guys. I mean, if you are seriously looking for change and that to some other technology at this time, then right now Hadoop is one of the best options because it's growing very fast day to day. Okay, so especially it has very vast market in US, guys. I mean, this is with the current technology. So if you go for big data, you know, the fact is companies are struggling a lot to get the big data, guys. Why? Because the technology started very recently. People are learning now. So if they want some experienced people right now, means how can they get? So the technology started. Okay, it's getting slowly. It's increasing its scope. So many companies are struggling with the lack of professionals, and even the people who have in the projects, maybe they don't know complete Hadoop. Okay, so that there is a very good market. So expecting more jobs in big data by 2015 and 14 and 15. So US has very major markets. Out of complete Hadoop market, USA only has major share, around 50. 64% of the Hadoop market is in only US, then following by India and other countries. Even the compensation also very good in big data. I mean, it depends upon how many ecosystems you learn. Okay, so basically here, with my friends. So basically here, if you see what is big data, so big data, first of all, okay, let me make it simple because we are going to discuss in detail about this in the course, in the first class. So in simple terms, if I say big data is not a software or framework, it's just a methodology. It's a methodology designed to build data-intensive distributed applications that runs on the clusters with commodity hardware and should be able to handle high volumes of data like terabytes, petabytes, and whatever gigabytes. Okay, so it's a methodology built to design the data-intensive distributed applications. Okay, that can run on high volumes of data and runs on the clusters with commodity hardware and should be able to reduce the latency time. Okay, so just a definition. Okay, it's a data-intensive distributed framework, a data-intensive distributed methodology. Okay, that so it can apply for the systems which can process high volumes of data. It can process high volumes of data and run some commodity hardware. So big data, right, basically runs with a rule called 3 V's: variety, velocity, and volume. Variety means big data can handle any variety of data, structured, semi-structured, or structured. Velocity means it can apply for both real-time analytics, batch analytics. Well, volume means it can handle any volume of data. So these 3 V's are very important, plays important role in big data design. So if you see here, Gartner saying that the data is growing very fast. So in the next 5 years, it's going to reach 8 times of what data? currently we are seeing. And this data, whatever is generating mostly is again unstructured. Okay, so this is a general definition. So we are going to discuss in detail about this file in the first course, about the characteristics and everything. So the volume of data, whatever is generating in big data, right, it's all mainly from different domains like web domain, e-commerce, shopping, banking, retail, telecom. Okay, telecom, it could be anything. The data again will be in structured and unstructured format, like relational data, or unstructured means it could be some text format, binary, image, videos, anything. So this is the data, friends, which is playing important role basically in big data. I mean, coming to decisions and everything. Okay, of course this also, but this is major since most of the data will be in unstructured format. So in our course we are going to do some image analysis. Okay, that is being implemented in Facebook. Okay, so we are going to do that algorithm in MapReduce. And then text analytics also we do something like recommendation algorithms or feedback algorithms. Okay, we are going to do some examples on this feedback algorithm. Okay, so we are going to do some of the use cases here. And again, friends, Hadoop again, it's not a single Hadoop. We have many Hadoops are available in the market. We have Apache Hadoop, we have Cloudera Hadoop, we have Hortonworks Hadoop, we have Mapper Hadoop, we have Pivotal Hadoop, we have Microsoft Hadoop, that is HV Lights, we have IBM Hadoop, that is IBM Big Insights, and Oracle has its own Hadoop, Oracle Big Practice, and AWS, Amazon has their own, that is AWS. So like this we have many Hadoops are available. Okay, so the difference is nothing else. All the Hadoops are built on Apache Hadoop. So Apache Hadoop is the base for all. Okay, so remaining all Hadoops are look like mostly similar, only they differ in terms of support. Okay, so in our course we are going to deal with the Apache Hadoop single node and multi-node installation. And then we are going to do Cloudera as well, a single node and multi-node. And we are going to discuss Hortonworks Hadoop, that is single node, we are going to do in our class. And then we are going to do it in AWS, in the cloud also, creating the nodes and see how in AWS as well. We are going to do the installation of the single node and multi-node. I mean, basically it's a, instead of AWS we have to say like what is that, the Amazon distribution, that is EMR and S3, Elastic MapReduce and S3 is the Amazon distribution of Hadoop. So we are going to use that. So we'll do the single node and multi-node installation of Hadoop on the cloud as well. Okay, so we are going to do all these installations in our course one by one. So coming to Hadoop framework is basically it's a data intensive, so it's a framework, it's a tool developed to support data intensive distributed applications at free of cost. So Hadoop applications are designed to work with some high petabytes of data. So basically this Hadoop framework, whatever I said, parallel processing mechanism, it's all was inspired from Google concepts called Google MapReduce and Google File System. So this is history of Hadoop, how it's been evolved, okay, from beginning to now. So Apache is a company which is going to support Hadoop, and okay, Apache Hadoop is a core Hadoop. On top of Apache Hadoop, these guys build their own products, okay, like Cloudera Hadoop, Hortonworks Hadoop, all those things. So we'll discuss about the history later. And these are the few users who are using Hadoop currently. I mean, the list is very big actually, but here we can see some Yahoo, Facebook, LinkedIn, Twitter, eBay, IBM, Regulatory, Post, PhD type access, Google, Adobe, New York Times. This is the largest cluster running on Hadoop by maintaining by Yahoo. Okay, so Yahoo is running more than 45,000 node cluster completely operational. Okay, so not only Yahoo, even Facebook running with 30,000 node cluster, so many things. So in our course, I mean basically Hadoop can fit for any domain guys. Okay, it can fit for financial, internet, retail, drug, healthcare, telecom, IT support. It can fit anywhere, any domain. Okay, so in our course, we are going to cover these ecosystems: Hadoop core, HDFS, MapReduce, Avro, Cassandra, Couchbase, Hive, Mahout, Pig. So Mahout we are not going to discuss because Mahout is phased out. The project itself is phased out. So by Apache, they are trying, they already closed this Mahout because it's failed, and now they are coming with some new ecosystems in place of this. Okay, so similarly like we do cover in our course Scoop, Fuji, Flume, HBase, Pig, Hive, all these things. So these are the some companies in US who are using the Hadoop. Okay, different distributions and everything. So this is our course curriculum. So course we are going to start with what is cluster, what is Hadoop cluster, what is big data cluster, what is the workflow in the Hadoop cluster. Okay, so we do discuss about the HDFS and the MapReduce, all these things. So this is all the part MapReduce. So the first 2.5 weeks we do spend completely on MapReduce because the MapReduce architecture is very, very important. Even if you don't know ecosystems, that's fine, but the architecture is very, very important. Okay, so we are going to do MR practicals as well after understanding the MR API here. Okay, so we are going to discuss anatomy again, which is important for interviews. So this is all part of MapReduce framework. Anatomy, types and formats, counters. So then the ecosystem started like Pig. Okay, then we do discuss about Hive, HBase, Cassandra. So all ecosystems we are going to cover. Scoop, Fuji, Impala, Flume, Avro, unit testing with AWS, Zookeeper. Okay, again Amazon Cloud. Okay, so these are all the ecosystems what we are going to learn. So ARN is one more new architecture of Hadoop. That is the next generation architecture of Hadoop. That is ARN, Eternal Resource Negotiator. Okay, so this is also we are going to discuss. Then as part of course, I'm also going to cover some 50 to 60% of admin topics related to Hadoop. Some 50 to 60% of the admin topics also I'll be covering in this course. Okay, so this is about demo guys. And even I'm going to take two projects, real-time projects in our course. One project I'm going to show you the design, implementation and running of it, and one project I'll give you for practice as well as I'll share the code. And I'll be taking one class for the certification. So who are planning to do certification, I'll just explain how could be the pattern, how to prepare for certification. Okay, and all the materials and everything you will receive from Google Drive, friends. Okay, so you'll be receiving from Google Drive through your, through the coordinators. Okay. So materials wise, you don't need to worry. There is plenty of material. Okay, installation manual, softwares, books, presentations, exercises, use cases, projects. Okay, how we have some good real-time projects as well on verticals. Okay,
Okay.
and um, so that's and along with this, okay, so the sessions, right? I think the record